This is section 10.2, learning about combinations and the binomial theorem. A combination is a selection of R objects from a group of N objects where the order is not important. We talked about permutations in the past, and permutations are when you have a list of objects and you're going to arrange them. You're going to put them in a different order. So if the order changed, the permutation counts that as being differently. This is a combination. If the combination changes the order, but it has the same elements, we keep that the same. That's the same count. Just you can think about a triangle. You can name a triangle 6 different ways with 3 points, but with 3 points you can only draw one triangle. So it's kind of a point of view of how you think about it. To calculate a combination, we use the NCR. The number of combinations of R objects taken from a group of N distinct objects is denoted using our formula. This formula is very similar to permutations, except we're also dividing by another value that is going to eliminate all of the repeated changing those values, rearranging those values. So we'll try it here. We see that the N value equals 5, the R value equals 3. So we're going to say 5 factorial over 5 minus 3 factorial times 3 factorial. That gives us 5 times 4 times 3 times 2 times 1. 2 times 1, because 3 minus 5 is 2, and 2 factorial is 2 times 1, times 3 times 2 times 1. You can reduce that, and the 2 can still reduce with the remaining 4, so we get a value of 10. So 5C3 is 10. We can do that with the next problem also, or you could come in to use a calculator. Using a calculator, you can notice if you type in what you're going to do first, which is 7, and then hit the math button, scroll over to probability, and the NCR button is the third one down. You can also see the NPR button is for permutations. This is combination, so we're going to use the NCR button. Then you put down how many of these R objects that we have, and we're going to be choosing, in this case, 2 objects. So a way to think about this is if you have 7 objects, kind of like 7 friends, and you're going to choose 2 of them, how many ways could you choose 2 of them? You could take the first friend and the second friend. You could take a first friend and a third friend, a first friend and a fourth friend, and so forth. There are 21 ways to choose 2 friends from a group of 7 friends. So 21 ways. These cards, we have some quiz questions and test questions that will deal with a deck of cards. So if you're not familiar with cards, this is your best cheat sheet, and you'll have it available for any quiz or test or exam that has questions dealing with cards. If you look here, you have 4 suits. You have a suit of clubs, you have diamonds, hearts, and spades. The hearts and diamonds are considered red cards. And the spades and clubs are considered black cards. So, if the order in which the cards are dealt is not important, how many different 4-card hands are possible? You're going to be given 4 cards out of 52. How many different hands are there going to be? Well, how many do we have to choose from? We have to choose from 52 cards. This is a combination because the order that the cards come into your hand doesn't matter. If you rearrange them in your hand, it's still considered the same hand. So it's just a group of cards. And you're going to have 4 inside that group. So using your calculator, 52 NCR 4, that's going to give you 270,725 hands. You can also consider in how many 4-card hands contain all cards of the same color. So you want all the cards to be black, you want all the cards to be red. It doesn't matter what cards you get, you just need them all to be the same color. So the first question is, how many colors are available? You have 2 colors to work with, and you hope or expect to get only 1 color. So that's the 2C1. Then you're also going to be working with all the cards of that color. How many cards have the color that is selected? Well, in a 52-card deck, there's 26 cards of the same color. 26 red ones, 26 black ones. So it really doesn't matter which color you get. There's still 26 cards to work with. And you're going to choose 4 of those. So 2C1 is a value of 2. 26C4 is 14,950. So when you multiply this out, you get 29,900 hands of the same color. On page 2 of our 10.2 notes, we're going to be looking at situations that you want 2 events to both happen. So it's event A and event B occur, or if event A or event B is going to occur. 2 different situations. The A is going to mean to multiply. That's the hint that it tells you to multiply. If it's an or question, you want one thing or the other to occur, you're going to add them together. So if you think about the Student Senate consists of 6 seniors, 5 juniors, 4 sophomores, and 3 freshmen. How many different committees of exactly 2 seniors and 2 juniors can be chosen? You want a committee to have 2 of each class, and how many different options would there be? Well, first, you're going to look at the number of ways that you can pick a senior. You notice that there are 6 seniors, and you're going to choose 2 of those. It doesn't matter what order you pick them in. There's no president, vice president, secretary. Order doesn't matter. It's just going to be choosing 2 for a random committee. Then you're going to choose 2 others from the junior class, and the juniors have 5. 5 representatives from the juniors, and you're going to choose 2 of them. How many different ways could this occur? How many different committees could possibly be formed? So when we calculate this, we're going to use our calculator to show what 6C2 equals. And that will be 15. We'll use our calculator to figure out what 5C2 equals, and that's 10. So that gives us 150 committees that could be made with that scenario. Next, we're going to look at how many different committees of at least 14 students can be chosen. How many different committees of at least? At least means this much or more. So if you're going to have 14 students in the committee, you're going to at least 14. You're going to have 14, or you're going to have 15, or, which means plus, you're going to have 16, or 17, or 18. That's why you add these values together, because it's an or. You're not going to get 14 and 15 students in this committee. You're going to get one or the other. So we first need to figure out how many students are possible. So when we look up, we see that there's 6, there's 5, 4, and 3. That's 18 students possible. We have 18, C14. Or we're going to choose 15 of those 18. Or we're going to choose 16, 17, or we're going to choose 18. Using our calculator, we can do 18 NCR 14. We'll find out that there's 3,060 different ways that you can pick 14 students out of that 18. There's 816 ways you can pick 15 students. 153. There's only 18 ways that you could pick 17. You're going to pick 17 students. You're not going to pick number 18. Or you're not going to pick number 17 or 16. Or you might not pick number 15. You would work your way down to show that there's 18 different ways. Essentially, you're leaving one person out in all the different ways. 18C18. If you're going to take all 18 people, there's only one way to do that. They're all in the committee. If you add this up, you're going to get 4,048 committees. We can also solve these same type of problems using subtraction. Counting problems that involve phrases like at least or at most are sometimes easier to solve by subtracting possibilities that you don't want from the total number of possibilities. During the year, the girls' basketball team is scheduled to play 10 home games. If you want to attend at least 3 games, how many different combinations of games could you attend? You're going to go to 3 games, or you're going to go to 4 games, or to 5, or to 6, 7, 8, 9, or you're going to attend all the games. Okay, what we're going to do, we're going to try and find the total number of ways to attend, and we are going to subtract the number of ways to attend 0, 1, or 2 games. So essentially there would be less to calculate. On this first example, we'll have a lot to show you, but there will be some shortcuts that you can take as we learn about Pascal's triangle and some of the shortcuts to figure out the total number of ways. So the first thing we have to do is find out the total number of ways that you can attend games, of those 10 games. There are only 2 choices. You either go to the game or you don't go to the game. You can think about it as 10C0, 10C1, 10C2, 3, 4. You'll attend all 5 games. You'll attend all 6 games. 7, 8, you'll go to all 9 games, or even attend every single game. Using your calculator, you could come up with that long list. We'll talk about what those long list is going to be, but the shortcut is to use the concept that all the different ways that you could possibly show up is equivalent to 2 to the 10th power. You have 2 choices. You either go or you don't go. out of 10 games, you have that 10 times. So if you're going to use all the different ways possible, that would be 1,024 ways possible. That's the shortcut method to figure out the total number. Now if we're going to look at the number of ways of attending just 0, 1, or 2, which is the ways we're not considering coming, there's one way to go to 0 games. You don't go to any. There are 10 ways to go to 10 games. You either go to the first, or you go to the second, or the third. There are 45 ways to go to 2 games. That's a total of 56 games if you're going to go to 0, 1, or 2 games. So if there are 56 ways to go to 0, 1, 2 games, 0, 1, or 2 games, then we're going to take the total number of games and subtract 56 from that to show you the number of ways that you can attend 3 or more. 968.